In this video, we want to take a look at how to solve a system of nonlinear inequalities, such as the one shown here, consisting of x squared minus y less than or equal to 0, and 2x squared plus y less than or equal to 12. As with any system of inequalities, the first step is to graph the corresponding equations. So if we look at the first inequality, the corresponding equation will be x squared minus y equal to 0. And this can be rearranged by adding y to x squared equals y, or y equal x squared. This we know is the standard parabola whose vertex will be at the origin and opens upward. The corresponding equation for the second inequality is 2x squared plus y equal to 12. And we can solve this for y by subtracting 2x squared from both sides. And so we'll obtain y equals 12 minus 2x squared. We observe that this is also going to be a parabola. Its vertex is going to be at the point 0, 12 because of the constant 12 here. And because the coefficient of x squared is negative, it will actually be opening downward. So our region will look something like, or our graphs will look something like this. We have our standard parabola opening upward. So we'll draw in blue. This is y equal x squared. And we have a y equal 12 minus 2x squared, which will have a vertex up here at 12 and open downward. Now, by choosing a test point and checking the various inequalities in a system, we observe that the solution set is going to be the region between the two curves, in particular the region above y equal x squared and the region below y equal 12 minus 2x squared. This region does have sort of four key points that we can identify. So here I've drawn these points in purple, sort of the top, the bottom, the left, and the right point of the region. Of course, the bottom point and the top point are known. Those are the vertices of our two parabolas, so 0, 0, and 0, 12. But we'd like to know the coordinates for the other 2 points. These would be the points where the red and the blue parabolas intersect. And so we can solve the corresponding system of equations in order to determine those points. So that corresponding system would be x squared minus y equals 0 and 2x squared plus y equal 12. In this case, as these are written, we can simply add them together to eliminate y. And so we'll end up with 3x squared equal to 12. From that, we see that x squared will be 4 by dividing by 3. And then x will have to equal plus or minus 2, which is the square root of 4. And so we have 2 possible values for x. This is consistent with the graph that we saw previously, as there were 2 points with different x coordinates, one positive and one negative, where the graphs intersected. To find the corresponding values of y, we're going to substitute these into one of the original equations and solve for y. In this case, we'll substitute each into the first equation. And so if I pick x to be 2, the first equation becomes 2 squared minus y equal to 0, or 4 is going to equal y. So we get y is equal to 4 in that case. If we substitute negative 2 into the first equation, we get negative 2 squared minus y equals 0, which also yields 4 minus y equals 0, or 4 equals y. And so for both values of x, we get a y value of positive 4. Again, consistent with our picture where the 2 points of intersection appeared to have the same y value. And so our 2 points that we needed to identify are the points 2, 4 and negative 2, 4.